Hello, 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 so can you all hear me?
Yes.
Okay, all right. All right, so let me start. Okay, all right, so we will start with some advanced concepts in SQL. So just to refresh that SQL, the basic query form is of this, the basic SQL query is of the form select from where, and so it is equivalent to the corresponding relational algebra query, etc. But before I go any further,
sorry, just
yeah.
one second before we are, because two guys right now, let's give like a couple of minutes. I would like to ask to the students who are here, Mark and Edwin, how are you finding this course? Like, are you finding it difficult? If you would like wanted to, what was your initial expectation from the course? What you want to study in the last two, learn in the last two lectures? Just can you give us some feedback? It will be very helpful, because we are offering this database course for the first time, and we just want to tailor the course so that it meets your requirement.
Yes.
You can unmute and just speak up. Mark, you have to say something? Any feedback?
Hi.
Or... Yes.
Hi. Yeah, so for me, I think right now I thought we'll be more on the practical stuff, because now I know the basic theory behind it, but like actually doing this SQL, like doing this codes on using SQL, it's like I don't know whether I'll be able to do it very well. But I get the underlying theory behind it. I know why we're doing this, but like actually doing that's my only concern. But every other thing is fine, because I get the basics and the theory behind everything we're supposed to do, but then actually writing this code, that's all.
Okay, good. Mark, you have to say anything? Thank you.
Okay. All right.
Okay, Mark has written, I like it. Okay.
Okay.
Yeah,
Right.
at any point when you find that this something is not making sense, or you're finding it difficult, the reason why we have this live course is that you can stop, you can ask that something which was discussed in like last lecture or lecture before, you want to go over it again, all those things could be done. Okay, and if you want to set aside some time outside the lecture, if you don't want to disturb the class and go over some topic, that could also be arranged very easily. Okay.
Yes. So if you think there can be, yes, you can ask me questions offline also. I'll be very happy to engage in that. All right. Okay. So any feedback on the quizzes and the practice sessions? So did that help? Okay. Good. Great. Okay. All right. So they helped. Good. All right. So then let's start today's. So today we will be covering some advanced topics in SQL. Okay, and one of the most intriguing topics or advanced topics is what is called a nested subquery. So essentially, nested subquery meaning there are more than one query. So by more than one query, I actually do not mean that there are two queries. It's one query, but there are more than one of this query form, select from where. So what happens is there is an outer query, which is the overall thing that you want to do. But to solve it, you require something which is an inner query or a nested query. So this inner query can occur in the where or the from clause of the outer query. Correct. And this can be used. I mean, this has got multiple usages, and in fact, most real life queries, most will actually use some form of this nested subqueries. I mean, many of them will use some form of nested subqueries. Okay, so let's go over them in a little bit more detail. Let's try to understand these things. So one important thing is that the inner query is evaluated for each tuple in the outer query, and we will see exactly what does that mean. Okay, and again, there is a very important concept called a correlated query. So now you see there are essentially the outer query and the inner query. And what happens is sometimes the inner query can refer to an attribute in the outer query. Then this is called a correlated query. So the inner query is not really independent. It will require a variable or whatever some variable from the outer query. So and that is why these are called correlated. So it is related. So the result of the inner query will depend on the variable that is being picked from the outer query. Okay. So again, we'll see examples for each of these cases, but let's start with something simple, which is called set membership. So set membership, essentially, it is trying to say that whether a particular object is part of a collection of objects or not. That's what called is set membership. So for example, if we just want to find faculty members who have not offered any course, okay, then what we will do, so okay, we are using that same old I mean whatever we did in the last class, those same that course offering faculty member, all those things, that kind of schema. So here you see what is happening is that here is an example of a nested query. Okay, why it is nested? Because as you can see that the overall query is this select from where, and the inner query is this select from, and this select from is within the where clause of the outer thing. So that's why this is the inner query and this is the outer query or the overall query, and that's why this is a nested query. Okay, now let's try to deconstruct this query. How does it work? Okay, as I said, so the inner query is evaluated for each tuple in the outer query. Okay, now let's see what does it mean. So we say select star from faculty where if ID not in, all those things. Okay, now whenever we say from faculty, that means we are going to evaluate it on every tuple from this faculty relation. Okay, we are going to evaluate it. What are we going to evaluate it? We are going to evaluate the where clause. Fine. So we pick up a tuple from the faculty, we evaluate its where clause. So what is the evaluation? We are saying that for that particular tuple is the faculty ID not in this set. So what is this set? This set is, then we solve this query. We say select instructor from offering. So essentially what does select instructor from offering do? It selects all the instructors who have offered one course. Okay. So that gives you the set of all instructors that have offered a course, at least one course. So that gives you the set. These brackets actually give you that set. And now we are testing for each tuple from faculty whether it is in that set or not. If it is not in that set, that means this faculty ID member is not in the set of instructors who have offered the course, which essentially means this faculty member has not offered any course. Okay. And so that is how this nested query helps, or that is how these nested queries are working. All right. So it is, well, I mean, okay. So this is how the first simple thing about set membership is being done. Let's see if we move forward. There are attributes in both the inner query and in the outer query, correct? So it is always a good practice to qualify the attribute. Now, what do I mean by qualifying the attributes? I mean by qualifying the attributes is you give those relations from where the attributes are picked some name. Okay, let's say faculty as F, and then you say F dot FID, and then you say offering is as O, then you say O dot instructor, things like that. So you always qualify so that it is not ambiguous to the reader who is reading that query, and even when you are debugging it later or trying to understand it better, it is obvious that this is what this is what the query writer meant. Okay. And similarly, it is always better to rename these relations if it is used in both the outer and inner queries. I mean, the same relation can be used in both outer query and inner query, then it is better, much better to rename this. For example, if you're using faculty in the outer query, you can call them faculty as F1, and then if you're using it in inner query, you can say faculty as F2, and then whatever you read, you can just say F1.fid or F2.year or F2.name or whatever. I mean, that's just unambiguous, and that's just a good practice to have. Okay, all right. If, however, there are people who have, we will write this unqualified attribute that will refer to the innermost query. Okay, so if you get an attribute that is not qualified, that means you are not saying f.fid, you are just saying fid, then which fid does it mean? It will, as a rule, mean the innermost query. Okay, so this is just to remember, to understand, given a query, how to look at it. Okay. All right. And as we already said, when a nested query refers to an attribute in the outer query, this is called a correlated query. So let's take an example. So this is an interesting example. So find names of all students who have taken a course with an instructor with the same name. So the idea is that, I mean, suppose an instructor has a name ABCD. If there is any student in the course, in a course that she has taught or she is teaching with the same name ABCD, you want to find such cases. Okay. Let's see how this is done. Okay. All right. So this is done in the following way. Okay. You see, let's construct it. I mean, it looks a very large query, but let's just try to understand it bit by bit. So select student name. Okay, that's fine because that's what we want. From, we are using three tables here: registration, student, and faculty. Okay, we are using all these things, and you see I am now renaming this. So I'm saying registration as R, student as S, and faculty as F. Okay, so this is I'm doing because so that this is a good practice, and I can use things like s.role is equal to r.role and s.name is equal to f.name and so on. Okay, now let's go inside the where query. The where is saying s.role is equal to r.role. So that means the student is registered in that course. The student has the same name as the faculty member. But one piece is missing, right? The student is registered in a course, great, and the student has the same name in the F, but F must be also teaching this course, right? So to do that, what we are doing is the following. We are saying f.fid in. This is, remember the set membership, f.fid in some set, right? Which is the inner query is solving. Now, very importantly, please understand this, that the inner query is actually a correlated query. Why it is a correlated query? Because you see it uses this variable R, which is from the outer query. This R is actually coming from the outer query. There is no R here, okay? So this is actually coming from the outer query. So what does this inner query is doing? It is essentially selecting the instructor from the offering such that this instructor, the course that the instructor offered, which is the offering.course code, is the course that you are interested in, is the registration thing that you are interested in, right? Because, so which means that this faculty member has offered this course R, the student is enrolled in that course, and the student name is equal to the faculty name. All right. So if this is clear, please tell me. If this is not clear, please also tell me, but we'll see an example later on. So please see. And importantly, this inner query is evaluated for each tuple in the outer query. What does it mean? That for every tuple here in this cross product, this will be evaluated. Now you see, for every tuple, the value of r.course code will change depending on from which tuple you have picked up from registration. If you have picked up which tuple you have picked up from registration will actually determine this r.course code. So this changes from tuple to tuple. And you are basing that value on that particular course code. Okay. All right, let's see an example. Fine. So here is the same query, and let's see. Here is an example. Okay. So this is a tiny toy example. So suppose the student roll number is 11 and the name is AB, 12 is CD, and so on and so forth. There is a faculty member who's 101 has the same name AB, and then this is happening, and the registration course code at roll is the following. Is the so the course code 1. So in the course code 1, roll number 11 is had registered. Roll number 12 had registered in course code 2, and roll number 3 has registered. Great. Okay. Okay, great. So then, if you just do the first part, s.roll equal to r.roll and s.name is equal to f.name. Let's forget about the inner query for the time being. If you just do that, then it produces an interim table like this. Okay. Why is this? Because the r.roll has to match s.roll and the s.name has to match f.name. Okay. So this produces the first thing 1, 11, then 11 AB, then 101 AB. Correct? That's the first thing. And you see the second one is also produced. So 3, 13, 13 EF, and then 102 EF. Okay. Now, before we go forward, let's see. Can someone tell me what is the answer to this query? So which one is the correct out of these two tuples? Which one is the correct answer to this query, and which one is not? Can you take a guess? Can you try to tell me? So which of these two queries help? Okay, now let's see. Is the first one an actual answer? It is, because look here. I mean, we need to. Is it an actual answer? Can you say this before you know what the offering is? You do not know, right? So now look at this. So here is what the previous table is saying. Now I am telling you that this instructor 101 offered course code 1, instructor 102 offered course code 2, and instructor 103 offered course code 3. Great. Please, now you should be able to tell me which is the correct answer. Is this a correct answer or is this a correct answer? So is this tuple a correct answer? What does this mean? That there is a student 11 who took a course 1, correct? This course 1 was actually offered by 101 and both of them have the same name. So this is actually a correct answer, the first one. However, let's look at the second tuple. The second tuple said there is a student roll number 13 who took a course 3 and that faculty member with whom the student's name matches is 102. However, very, very importantly, 102 did not offer the course that the student took. 102 offered course 2, but not course 3. So this should not be part of the answer, because see, there is a faculty member 102 whose name matches with this roll number 13's name, right? But the query asked that if the faculty member has to offer the course which the student took. The student took the course 3, but the faculty member offered the course 2. So they are not match, which the student also took, and their names match. So they are part of the answer. Okay. Now let's go forward. Let's see. Let's try to see what is happening here. So now, if you say so, okay. Here, now let's try to understand the inner query, working on the inner query. The inner query says r.course code. Now the r.course code is 1 for the first tuple. For the first tuple, the r.course code is 1, right? So that means we are choosing the instructor. We are choosing the instructor who has offered this course code 1, and that is only 101, right? Now, so the FID here is 101. So is 101 in the set 101? It is yes. So this tuple is actually an answer. For the second case, The course code becomes 3. So the offering this thing, the inner query chooses only the set 103, because who has offered course 3? Only the instructor 103. And what is the FID for this thing? The FID is 102. So is 102 a part of this set 103? It is not. It is not. And therefore the tuple is not returned. And therefore this is not an answer. However, this is an answer. Okay. Is that clear to everybody what is happening? Okay. All right. Now, very importantly, we use this r.coursecode as a, this is from the outer query. So this r is actually linked to this r. Suppose somebody said, well, I mean, I can have another registration here and say that is the registration code that I want, okay? So essentially that person has written this query as registration as G here, and then instead of using the correlated query, instead of using the variable from the outer, that person is using the variable from the inner query. Okay. Then you see what happens is then if you go ahead, the inner query now is no binding on r.role. It's just every course code that has been offered, right? So that's so anybody who has offered any course will be returned. So the inner query now returns the entire set 101, 102, 103. And now, of course, 101 is part of that, so that is passes. However, erroneously, 102 also passes. So this also is returned as an answer, which is wrong. Which is wrong. So the point here is if you put it an inner query here with the same binding with the local thing, and if you do not bind it to the outer query's registration, then you will be getting this as wrong. Okay. Then the answer will be wrong. Okay, so please do keep this mind that the non-correlated query can result in an error. Okay, so you require that correlation, you require this to be r.coursecode. Okay, is that clear with everybody? Okay, right. So if you have a question, please you can type to me, or you can just speak out. Fine. Okay, let's move forward. Okay, there are certain things in SQL called set comparison. So the set comparison meaning there is something called sum. Okay, SOME sum. So that means so let's look at this example. So is 5 less than sum of 0, 5, 6? So what does it mean? Is there anything for which this is satisfied? Is there some element for which this is satisfied? If that is true, then it passes. This is true. Why this is true? Because 5 is less than 6. There is an element for which 5 is less than 6. I do not care about the other elements. If there is one element that it passes, then it is true. However, for this case, for none of the elements this passes, so this is not true. For 5 equal to sum, this is true. Interestingly, 5 not equal to sum is also true, because see, the first case, there is an element that is equal to 5, and then there is another element that is also not equal to 5. So both are true. Okay. So the sum is essentially, it's saying equal to sum is essentially saying whether this is a set membership or not. Okay. So if you want to say find roll numbers of students who have CPI greater than some student in CSE, you can say something simple like this. So you say select roll from student where CPI greater than some. So you find out the CPIs of all students from the department equal to CSE, and if it is greater than someone, then you are happy. Okay. Great. Similarly, similar to sum, there is something called all, and the all, the sum is if there is one element that satisfies, then it is okay. But for all, every element has to satisfy. So everything in this set has to satisfy. So if this, for this to be true, 5 has to be less than 0, 5 has to be less than 5, and 5 has to be less than 6, all of them. Of course, that doesn't happen, so this is false. Here it happens, so this is true. Here it does not happen because although 5 is equal to 5, it is not equal to 0, this is false. And 5 not equal to this is true, and so on and so forth, right? So, all right. So again, if you want to find the roll numbers of students who have CPA greater than all students in CSE, then you have to use this variable. I mean, you have to use this construct all. Okay. Okay. Great. Then there is something called an empty set. I can test whether some relation is empty. That means it. What does it? It means to be saying a relation is empty, meaning it does not have any tuple in it. It doesn't even have a single tuple in it. Okay. So, for example, if I say find faculty members who have offered courses this thing in this year 2018, then I can say the following thing. Okay. Look at this. This is again an correlated query. So I'm trying to find out the faculty ID from faculty as if I'm renaming it, where it exists, where that means exists meaning this set. If this set is non-empty, then this passes, this is true, otherwise this is false. Now which set is non-empty? So I'm saying select instructor from offering. So the instructor is equal to f.fid. So for the particular faculty member, for the particular tuple that I'm testing, I'm looking at that faculty member. And the year is 2018. That means this faculty member has offered this course in the 2018. If there is such a tuple, then this set is not empty. That means this exists passes, and then you return that faculty member. Okay, all right. So the other way, not if we have not offered any courses when not exists. So. Okay, all right. So is that clear? So again, this is another correlated query. This is tested tuple by tuple on this faculty member, and that you're finding essentially the offerings in year 2018 by that particular faculty member. And if there's such an offering, then this set is not empty. Then this faculty member passes this test, and you are returning it. Otherwise, you are not. Okay. Similarly, you can test whether the relation contains duplicate tuples. That means are things unique there. So that's again. I mean, we can construct an example saying find faculty members for only one course in this thing, right? So that means again, you see, I am testing this. Whoever has offered only one course. So if this set contains only one value, then this unique thing passes. If it contains multiple values, then it does not pass. Correct? So if this is one value, then it passes. So then this is true, and you are returning it, and otherwise you are not doing it. And similarly, you can use the not unique thing as well. Okay. So please do ask questions if you have some questions. Okay, you can also just actually type down values literally. So this 33 number is a typo here. This should not be here. So essentially, you're trying to find out students in computer science and economics department. 33 is a typo. So there you can actually type down things literally, saying CAC. You're actually typing it down, CAC, eco, and all those things. Okay. All right. So to summarize, this is the format of the SQL query. It may contain up to 6 clauses. It may be nested, and only the first two, the select and from, are mandatory. And the format in order to write it is that select from an attribute list, from a relation list, where you pass some predicate or tuple condition. You can have a group by grouping some attribute list and having, that means that group has to pass that condition. And finally, you can also say order by. You can have a list of attributes to order by. Okay. This is the way to write down the syntax of SQL, but how are they evaluated, or how are they actually executed? So which is the first thing that is picked up for execution? This is essentially the from, right? Because I need to know from which relation I need to pick up tuples to execute, correct? So once I pick up those tuples from, I am doing it tuple by tuple, then I'm testing this condition, the where condition, for tuple by tuple. Great. And from the tuples that pass these two, then I'm passing it on to the group by saying, okay, now I have these tuples, please group them according to this attribute lists. Then once the grouping is done, I am saying, okay, I'm only interested in those groups that have that condition, the having the group condition. So at the end of this having, I have some groups that pass the candidate, and then I am selecting whatever attributes I want to actually, and whatever I'm actually interested in the output of. Once you have selected the attributes, finally you are ordering them because in the display, I want them in the ordered manner. So the execution order is first from, because you're picking up tuples from, then you are passing it through where to see which tuples are passing. Whichever passes, you are then grouping them by the group by. Then for each of such groups, you are testing the having condition, whether the group should qualify or not. If the group qualifies, you select the attributes chosen for the final display, final output. And then the last one is ordering. You are ordering you are sorting for the, so the final, the display is ordered by this. So although the syntax says select from where group by or having order by, the execution order is actually from where group by having select order. Okay. All right. Fine. So any more questions on this SQL? Okay. I can also use something called a derived relation in the from clause. So for example, let's see this thing. So the nested query need not always be in the where. The nested query can be in the from as well. So I'm trying to find out departments and average CPAs where the average is greater than 8. So what I'm doing is, you see, I first solve this query from. So because I need to evaluate from first, right? So I'm solving this query, department, average, CPI, group by, blah, blah, blah. And I'm calling them as, this is a renaming, correct? I'm calling this output of this as department average. And I'm calling those variables as department ID and average CPI. So now I have this table ready, okay? Once I have this table ready, then I'm selecting from, so selecting the tuples from them and just checking this condition. I'm checking this condition average CPI greater than 8, and then just displaying them, selecting them. Okay, so this is called a derived relation. Why it is called a derived relation is that this relation is first derived, and then you are using it in that outer from. So the inner query is first solved, and then you are using it in the outer from. Okay. Great. So this avoids using the having clause, but it's a matter of choice of how to write this and all those things. But yeah, it's up to the query writer, whoever writes this query, how to write. Okay. So then we all studied a little bit of join. Remember this join that so the join is if we have this natural join, then we pick up the attribute that is common and just match them. So only if they match, we return them. So this will return this 1, 1, and 2, then 1, 2, and 2, because this 1 matches, and then 2, 1, and 3. Right? So these two match with the first one here, and the third one matches with the second one, the last one. That produces these two. This is the natural join. Similarly, there is equality join and all those things. Okay. So the natural join only chooses things that match. Okay. Now, sometimes you will require information of the things that do not match as well. So to achieve that, there is something called an outer join. Okay. So let's see. So there is a left outer join, a right outer join, and a full outer join. So the left outer join, when you are saying our left outer join is, that means it will first do the join, and then whichever tuples in R do not match, it will also output them. It will also output them by, okay, but since it does not match, how will it output them? It will use this value null. So it requires the use of null values and it will output. So the right outer join will do the other way around and the full outer join will do the both cases. But let's look at an example. But just before that, just to remember that because these are called outer joins, the ordinary join is sometimes called an inner join. Okay, the inner join, because there is an outer, so the opposite is inner. And because the left outer join, you can actually omit the word outer and you can just call them as left join. And you can call the right outer join as right join and the full outer join as full join and so on and so forth. Right? It's just, you can omit this. Okay. All right, let's look at an example. So suppose this is the table. These are two tables and I want to do a simple join. This is actually an inner join, simple inner join. So what is the output of this? See, 1 matches with 1. So I will have an output 1, 5, 7. Okay. Then 2 matches with 2. So then I will have an output 2, 6, 8. Right. Now 3 does not match with anything else. So I will not have any output corresponding to this. And similarly, for 4, nothing matches. So I will not have any output corresponding to this. So the only output I will have is this. Okay. This is the normal join. Okay. Let's see. For a left outer join, what will happen is that again, we will start doing the same way. So 1 matches with 1. So we will have 1, 5, 7. 2 matches with 2. So we will have 2, 6, 8. 3 does not match with anything. However, since this is a left outer join, I must produce 3. I must produce everything that is here. So how should I do? I know, so the schema, so I will have to have an A and a B and a C, right? So I know the A value is 3. I know the B value is B value is 7. What is the C value? I do not know there is any C value, right? So I will essentially say that, look, I do not know, but since I have to output it, I will put a null here. So the correspondingly, this will have a 3, 7 null. Okay. Please do understand the difference from a inner natural join to a left outer join. I mean, so it computes the inner join and then whatever is left, it plugs it with null values and outputs it. Now, if you have understood this, the right outer join is analogous. So this 1 matches with 1, 2 matches with 2. The 4 does not match with anything. So it will have a null. So it will have a 4 null because the B value will be null. 4 null 9. So this is what it will happen. Okay. Great. All right. Then let's move a little forward. And we have done left outer join. We have done right outer join. Then we can do a, so this is a normal outer join. We can do a full outer join. The full outer join is similar. I do a 157. I do a 268. Then I need to produce tuples from both this set and both this relation and this relation. For this relation, I can only do 3, 7 null. And for this relation, I can only do 4 null 9. And I will have both of them. Okay. So it essentially is a combination of both left outer join and right outer join. Okay. So 157, 268, 67 null, 4 null 9. So all this will be part of the outer join. Fine. Any questions on this? Okay. So the join conditions can be this, as I said, inner join, left outer join, or right join, full join, etc. You can also use something like a natural join, which is just matching those two values exactly. Then you can have this join on. So if you say student inner join program on meaning you are stating what the condition the join should do. So you are saying, well, the condition of the join is student.role equal to program.role. So you can say that. So that's on meaning you are essentially stating the predicate, exact predicate condition that you are doing. Okay. Similarly, you can have a join using. So the using will say that, okay, well, I need to join using these attributes. And whenever you say using, if you say a set of attributes, then it has to be an equality join. So what does an equality join mean? Is that, for example, if I say something like using role, that means I'm joining student with program using role. That means I'm essentially saying this is a shortcut to saying student.role is equal to program.role. That's a shortcut. Okay. So when I say using role, it has to be so the condition, when I say using, the implicit condition is an equality. It has to be equal. When I'm saying on, it can be any condition. I can say student.cpi less than program.cpi, whatever. I mean, you can say any such condition. Right? And when you say natural join, it's the same thing as using, but you don't even have to specify the attribute name, because when you say natural join, it will pick up the common attributes, the attributes that are common from student and program, and will join them using an equality. It's essentially the equality join on the common attributes. So just say natural join, and that's about it. Okay. So when you don't say anything else, when you just say join, then it means an inner natural join. So for example, and you can join multiple relations. So you can just say student join program join registration. So that means it is an inner natural join when you don't say anything. When you just say join, it means an inner natural join. Okay. Okay, great. If not, we'll move on to slightly different things in SQL. No longer queries, but a slightly different thing. Okay. So is that all right to move on to slightly different things? So is there any questions on this SQL queries? Okay, fine. So sometimes what happens is that a query is used many times. Okay, and you may be using a query in other queries many times. So for example, suppose you were the administrator of the department CSE. So you can say, okay, you want to do some processing of the students of CSE. So you want to say select students from department where, so select students where department equal to CSE. This you have to use again and again in your query, because that's what you are interested in. So what you can do is you can create something which is called a view. So view is a shortcut to writing this. Okay. So instead of writing this again and again, it's a shortcut. So it's a virtual relation. Okay. So it helps in query processing. So if a subquery is very common, you can obtain a view for this. So for example, if you have to use the student natural join program multiple number of times, you can just say create view student program. Okay. Now, once you have created this, look, this is not actually a query. The query is not actually being run. It is just saying that I am saying student program is a shortcut to student natural join program. So I can, of course, drop a view using these things. So I can use this. So for example, if I just say select star from student program where department equal to CSE, I will expand it at runtime. Because student program, I defined it is just a shortcut, right? So instead of a student program, I will expand this. So what will actually be run by the database is this query, but you are just writing it in a shortcut manner. That is all about views. Okay. So a view is not stored physically unless it is materialized, but we don't need to understand what materialization means. That's a database engineer's concern. We don't need to care about this. And just assume that the view cannot be updated. So there are no, this thing, a view is just a query. It is just for query. Okay. So is it clear? Is it clear of what a view is? Okay, all right. Let's move forward. And the next thing that we will study is something called a trigger. So a trigger is something which is like an automatic management, an active management. So it is done by the database engine itself and not by the user. So one example for trigger is that whenever let's say somebody gets a promotion, the salary should increase by 10%. Let's say that's a rule in a company, correct? So now, so you can write a trigger for this. So the trigger will be that whenever somebody's promotion changes, you set a trigger, the salary will automatically be increased by 10%. Why a trigger is useful? First of all, this helps you in processing. Second, supposing there is no trigger, then a database engineer or database manager or the database person has to remember to set two things. This, first of all, the promotion has been done. So he said, okay, the promotion has been done. So please change, let me please change the post of this person. And then she has to also remember to go and update the salary table and increase the salary to 10%, right? However, if you write a trigger, then this happens automatically. She just doesn't need to do the second part. So it is error free and it helps in maintenance and it's much better. So it just does one part and the other part is automatic. This is a rule. So it follows what is called an event condition action model, ECA model. So the event is there is a database modification, right? So something has been modified and the condition is, well, if that modification meets this condition, for example, here the modification is that there is something about the employee has changed. The condition is that that must be the post of the employee. And then the action is you go ahead and change the salary. So the action, that's the action. So it's the ECA model, okay? So, well, so it can be called before or after the modification. So, I mean, there are two types of things, right? So the new value refers to a new value of the updated tuple, or if a value is inserted, correct? And the old value refers to the old value of an updated tuple, or if the tuple is deleted, correct? So this is these are actual keywords. New and old are used, and by default this is for each row. So let's look an actual example. Okay, so let's say we want to do something like update the course code of an offering when the code of a course of type 9 is updated. Right? Fine. So now you see what I'm saying, that this is a create trigger. So this trigger is given a particular name so that you can refer to it later on. You're saying create trigger, then you're saying after update of code. So this means this will be an, after you've done this updation, then please use this trigger, okay? So after this update of code, that means whenever this value code in the relation, in the table course changes, after you have updated that, then please do the following thing, is that for each row of this, whenever the C type is n, this is a condition that not for every course, I'm not interested in every course, but only where the course type is n. For that course, please update the offering and you set that course code as the new code. So whatever is the new code that has become. So because the value of code has changed, right? So the new dot code meaning the new value of the code, correct? So and what does it mean? Course code dot old dot code means whatever the value is the old code that you change to the new code. That's what it is saying. The old code is changed to the new code. This update occurs as whenever there is some update in this thing occurs. Okay, so that's what that is what the trigger is. Of course, trigger can be deleted. You do not want that trigger to hold on. You can just delete. Please do remember that the trigger is written once, and this is invoked automatically by the database. The user cannot say, "Please run this trigger." It cannot. The trigger has some conditions, so those conditions have to be met to run the trigger. Okay, it will not be done otherwise. Okay, great. Any questions on this? Views and triggers? No. Let's then follow something called some things are called index. Okay, so an index on some attributes essentially means that, so okay, an index is help to search. For example, we all know that there is index in a book, right? How does the index in a book help? Because the index will say, okay, this word occurs in page so and so, right? This helps in searching the word. Otherwise, suppose there is no index and suppose you want to find a particular word in a book. What do you have to do? You have to go through that entire book to find it, right? That is made much faster while you're using an index. So the index will tell you, okay, if you want to find this word, please just go ahead and look at this page. Okay, that is done. So index that way is and index is called this on course C type. What does it mean? That I am indexing this value C type. I am indexing this course type, which is from the course value. So I'm just creating an index on this. So whenever an index is created, any search that anything that is searched on this course type C type will actually use this index automatically. You don't have to say please use the index. Once you have created an index, the database engine will of course automatically always use this index. Okay. So index will be used whenever this attribute is things, and often primary keys are implicitly indexed, but that's okay. So it slows down modification because the index is also modified, but that's not a big deal. And you can, of course, if you think that the index is not helping, so you can just drop the index. You can say, oh, well, I don't need the index. Okay. Great. Let's move a little bit forward. So SQL is also a data control language. What does data control language mean? It means that you can control access of users to data. So you can control this security features, etc. So how? You can say, you can use this grant command. So grant privilege. So the privilege, you can grant privilege, some certain privileges on some certain objects to an user. Okay, with some grant option. So let's see what does it. So the privilege can be all, or you can have specific privileges. For example, you can say for a table, this user can create a table, this user can alter a table, this user can drop it. Okay. For tuples, you can say, well, this user will be able to select some tuples, this user will be insert or update or delete some tuples, this user will be able to execute some functions on this tuple, on this thing. So these are the objects. So, and this can be on a table, on a view, on a procedure, meaning a function, etc. All of this. And the user can be somebody particular, having some role, somebody particular, or public, meaning I just want to give this permission to everybody. Okay. With the grant option, the last thing with grant option, meaning can this user also grant something more to others? So essentially, if you say, okay, this user, I give that user grant permission, that user herself can grant certain other privileges to certain other users. So that is kind of creating a hierarchy of these things. So the top level manager grants this to the mid-level managers with the grant permission, and the mid-level managers now assigns some privileges to the lower level managers, and so on. That's the this thing about your this grant. Okay. Of course, if you can grant, you should be able to revoke, and that's the way to revoke is this revoke object from this thing. Okay, revoke privilege. Okay. So, for example, you can say grant select on student to XYZ. So that means you are giving permission to this user who XYZ, so that the user are now able to select. So use this select on student. So user can essentially query the student. Okay. Look at the second thing, that you grant all on course to ABC. This means to user ABC and granting all privileges on the course table with a grant option, so that the ABC can in turn grant somebody else something. And then you are saying, okay, revoke create on student from XYZ. That means the student will no longer be able to create things on the student. Right? It will not be able to change anything. Okay, great. So as I have been saying, so the SQL standards have evolved a lot over the years, and different vendors provide different flavors and may not implement every feature. So it is best to look up the manual. Okay. So the particular SQL version that you will be using has to be, you have to see what exact version you are using and all those things. and that has to be modified. I mean, that has to be understood. What does it mean? I mean, so you have to look at the manual, etc. directly. Okay, so please see if are there more questions on this SQL. Otherwise, we'll finish SQL here and we'll move a little bit to transaction processing. Are there more questions on SQL? Okay. So I'm assuming there are no more questions. Okay, all right, so let's do a little bit of transaction processing and we'll have to see what does transactions mean. But the idea of transaction is that this is a logical unit of a program and it famously follows these 4 properties. These are called the ACID properties, ACID. Okay, and let's understand what those ACID properties are. So the first property is called atomicity. So the atomicity means that so whatever you call a transaction, either all the operations are reflected or none of them are reflected. So let's take an example of a transaction. And the most simple example of a transaction is a bank account transaction. So suppose A is sending money to B, right? Suppose say A is sending some money to B. Now, what do I mean? So actually, what are the operations there? That A's bank account is debited and B's bank account is credited. Okay. So when you debit, so there are 2 operations, right? So what I mean by atomicity is that either all this should be done or none of them should be done. So either both of these should happen or none of this should happen. So essentially what I'm trying to say is it should not happen that A's account has been debited but B's has not been credited, or B's have been credited but A's have not been debited. That should not happen. So it should either happen both or it should not happen at all. Otherwise, you see there is a problem. Correct? The atomicity, I mean, otherwise there's a huge problem. The bank will face huge problems. So that cannot happen. The second thing is this consistency. So if a database is consistent before a transaction, it must be consistent after it. So consistent meaning, suppose I say that, look, none of these accounts can have a negative balance, correct? That is a consistency check. And after this transaction happens, it should still remain consistent. So it cannot remain negative balance, right? So that's the consistent. Then the third property is called isolation. Isolation meaning, I mean, it may happen that there are multiple transactions going on, and this of course happens, right? So for example, A is transferring money to B, C is transferring money to D, E is transferring money to F, and so on. Now, when A is transferring money to B, it does not care, or it does not need to care whether C is also transferring money to D, or whether E is also transferring money to F. So it is as if that A to B is the only transaction that it needs to work. In fact, so much so that if A is transferring money to B and even B is transferring money to C, even then it will behave as if there is no other B to C transaction. So it will just be as if this is isolated from the rest of the world and it is just happening on its own. Okay. All right. The last property is called durability. And this essentially means once a transaction finishes, the changes are permanent. The permanent meaning once I get a message from the bank that this money has been credited to my bank account, even if the bank's website fails, that my money should be there. So it is permanent change. Even if there are subsequent failures later on, I don't care. Once it has been said that this has been done successfully, then it must remain successful. So these four are the very famous acid properties. Okay. So these are the transactions acid properties. So a transaction, as I said, it's just a logical unit of a program. That so the only thing that we'll be worried about in a transaction is reading an item and writing an item. Okay, we are not worried about anything else. So there are just two basic operations: read and write. So read X meaning I am reading this the value of this X, and write meaning I am writing a value to X. Okay, all right. So what are the conflicts that can happen with read and write is that there are three conflicts: RAW, WAR, and WAW. So that means read after write. So suppose there are two transactions that are reading. So one transaction is reading and the other is writing. And suppose both are writing, or both, I mean, one is reading, the other is writing. So then it is important that the order of operations be taken care of. Okay. If the order is not taken care of, then we can be in trouble. So because suppose I want to read a value and after which there is a write coming. So I must ensure that I have read it before the other transaction is able to write it. If not, then I will be reading a wrong value. I'll be reading the updated value, which I don't want to do. Correct? So similarly, write after write meaning somebody is writing one value, the other should be writing after it. Otherwise, there is a problem. I mean, the second write should be the actual effect, but then it will be it will be erased, or it will be modified by the first write, which should have come earlier, but that is not happening. Okay, so that is what I mean by this thing, this read-write conflicts and all those things. Okay, is that clear? So what are the problems that can happen in a transaction? Yes, so why do transactions fail? Transactions can fail due to multiple issues. First is a lost update, which is what we were just saying. The update by one transaction is overwritten. Then there is a temporary update. So a transaction updates and then fails, and another transaction reads it. So when a transaction fails, that means suppose the bank transfer amount has not happened. It has failed for some reason. So then it should be reverted back to the original amounts that were there in A's and B's now, right? So that's what's called a rollback. But suppose in the meanwhile, some transaction has read the value of B and says that, oh, I see that there is a new value which is so much more money and all those things, and it goes ahead. So that it should not be allowed. Okay. Similarly, there is a problem of incorrect summary, which means one transaction is updating, the other is computing an aggregate. So suppose again, this A to B, suppose a transaction is updating A and updating B, and the other is computing the sum of A and B, right? Now, the sum of A and B should be done in a manner such that either it takes both the new values of A and B or the old values of A and B, not otherwise, right? So this is called the incorrect summary problem. Then why do transactions fail? Well, there are multiple things, system crashes and all those things, these things. So a transaction can have this particular, so a transaction has this particular state. So a transaction can be active. Then once it finishes, once it does all its operations successfully, it's called partially committed. From there, it can commit. That means everything is now permanent in the database, the durability thing. Or it can finish from a partially committed state or otherwise, and then it is called aborted. Now, when abortion happens, then certain things may need to be written back and all those things. This is called rollback, and it has to be ensured that there is no effect. So if some things have been modified, this needs to be modified back. Okay. So to do that, there is essentially, this is called recovery management. So recovery management ensures that these are maintained, and we have a fail stop assumption saying that once the data is written on a hard drive or on a non-volatile storage, it is never lost. And it has got two things. This is not so important, we'll not go over this, but just so that you know. And then finally, there are these concurrency schemes, which essentially says, given if there are multiple transactions, how to ensure, there's a term called serializability, how to ensure that they are correct. That means all these problems of read after write and all those things have not happened. Okay. Fine. So that ends the SQL advanced and these things. So are there questions on this? Are there any more questions on this? So can we stop here today? All right, so we can stop here today. And well, thank you. So we'll meet in the last class. Okay, fine. Thank you.